Thank you all. We'll go ahead and get started. This is session 1B, which is there is no I in Roundabout. I'm Josh Hurst with Kittleson in Raleigh, and I'm excited about the Roundabout discussion today. I do want to mention a couple of things before we get started. Although first I'll say, before we jump into this session, if you have how's bingo going for everybody? If you have your bingo sheets, I don't know how things are going with getting those checked off, but if there's anything I can do to help, even though this session isn't focused on complete streets or multimodal, the roundabouts are really the pioneer in alternative intersections. So I'm excited about the passion and presentation skills of our presenters today. All right, I'll hopefully that's enough of a boost for y'all. Just let me know if I need to repeat any of that, or if there are words you're missing. Anyway, before we get started, I do want to recognize our sponsors. As you've seen, the sponsors cycling through, but I also want to recognize the sponsor for this session, especially KCI, who's sponsoring this session. So let me share a brief video for them from KCI and get this going. So all right, let's see, can you see the screen?
Yes, we can. Yes, we can.
All right, great.
Greetings, Southern District. I'm Bob Murphy with KCI Technologies in Nashville. KCI has offices spread throughout the Southern District. KCI is all for roundabouts and traffic circles. In fact, I'm so big on them, I live next to one. I hope you enjoy this awesome session.
All right, well, thank you very much to KCI for sponsoring this. I'll go ahead and I'll go ahead and get started on our introductions. Well, before we do introductions of our participants, of our presenters, I do want to encourage you to ask questions via the chat, and if you have a specific question for particular presenters, just specify which presenter your question is for. I mention that partly because two of our presenters are named Mark, so you'll want to specify which, whether it's Mark McCulloch or Mark Lenters, that your question is for.
One's better looking than the other.
And I'll let y'all figure that out. So so with that, I'll introduce our first session, which is or our first presentation is on mini roundabouts, and by Mark McCulloch. Mark has been with the Washtenaw County since 1999. He's a leader in the new trend of right-sizing roundabouts at high-speed approach intersections to enhance safety and improve efficiencies while stretching limited resources for other uses. Mark is a graduate of Michigan State University with a BS in civil engineering. And with that, I'll turn it over to Mark, and we're going to answer we're going to do all three presentations, and then we'll do questions at the end. So with that, I'll let you go, Mark.
All right, Josh, thank you very much. And for those of you out there in the internet's world, Mr. Lenters is the good looking one. I have a face for radio, so we'll keep my video off here. Well, welcome. Very pleased to have you all here. Really excited to be able to present here. Some of you may have already seen this presentation. So if you have, it's very similar. It might have a few tweaks to it here and there, but nonetheless, still happy to share with you what our experience here are in Washtenaw County concerning right-sizing roundabouts where we can. All right, here, get my cursor in the right position. All right, outline. So we'll start with why should we use smaller roundabouts where they're applicable? How can we minimize our costs? Because money is frankly what makes these things go around and make projects go happen. We'll talk about Pontiac Trail and 7 Mile. That's where the story all began back in 2013 here in Washtenaw County. And then how that project influenced us to try our first mini roundabout on a high-speed road approach. Coincidentally, Mark Lenters helped me design it. the textile minis. And then we'll jump over into Baker Road for any of those within the Southeast District that have, in the consulting world, that works for a DOT, or you yourself works for a DOT. This would be a great example. And once again, I'd forgotten to edit this slide. I did this presentation in Wisconsin, so my bad. So we'll just say, just pretend that it says DOT as opposed to Wiz DOT. We'll talk about some trade-offs because there's no perfect solution for anything. And then I'll talk about, from my perspective, what the recipe is for right-sizing success. Now, I always like to start off with this disclaimer. We've all been to a presentation where someone has gone up to the podium and they're trying to sell you something. And they will try to convince you that what they're trying to sell you is the greatest thing with pants with pockets. And although I am of the opinion that these smaller roundabouts, mini roundabouts, are a good solution where applicable, I'm the first to acknowledge that they come with trade-offs and they're not perfect. So just understand that as we go along, I'll point some things out to you. You're free to ask questions that we can get to at the end of the presentation. But I like to be very upfront with them, because what I realize is what's good in Washtenaw County may not be good for your community as well. And the last thing I'd want you to do is think you've got something that's awesome. And next thing you know, figuratively speaking, you're staring down the barrel end of a gun after it's done, because some people weren't expecting some types of outcomes that maybe you should have known about. So we'll talk about those. All right, so a little background for you of those that haven't been to Michigan, Washtenaw County. We're just outside of Detroit. Wayne County is Detroit. Ann Arbor is our county seat. I'm a Michigan State grad, so we don't like Michigan here. Just kidding. Population is 367,000 people. Now, we have, frankly, the best of both worlds when it comes to rural versus urban. What you see on the screen, that blue, is our urban boundary where we get our federal aid or urban dollars from. Everything else is rural. So we really have a nice balance between having projects that are rural and urban. We have 28 total roundabouts here in Washtenaw County, and of those, about 7 of them are what we'll call mini roundabouts or smaller roundabouts. That is the yellow bullseye with the purple around it. Just for the complete disclaimer here, I want you to, when I say small roundabout and a mini roundabout, one and the same. Okay. Now, if you get into the breakdown with Federal Highway, it'll tell you 90 and less is a mini roundabout. Basically, I'm going to tell you most of my roundabouts here are between 90 and 110. That's what I consider a small or a mini roundabout. So don't get hung up on that term there. Should I say something that's 110 and say mini? All right. So moving on, why smaller roundabouts? Well, from my perspective, it's because we can no longer afford the status quo. Last time that the federal gas tax was increased was 1997 as part of the Taxpayer Relief Act. And ever since then, I think it's like 18.5 cents per gallon that we were collecting that goes to Washington, D.C., and then just gets through, some are donor states, others are not, where the money is not evenly distributed. But on top of that, that revenue is not adjusted for inflation whatsoever. So we know that the cost of living, the cost of labor, the cost of materials has gone up substantially since 1997 to the point of 60% increase per the Bureau of Labor Statistics. So in the perfect world, if money were no object, if we had unlimited resources and we could build a traditional size roundabout of say a 130 or 140 ICD. ICD, for those of you that are new to roundabouts, is the inscribed circular diameter. It's basically think of it as the diameter of the roundabout itself. If you can build between 130 and 140, I'd say great. But the reality is we don't have those unlimited resources. So instead of trying to do more with less, what I like to say is I like to do more with what we have available to us. And I feel like we've really come a long way, Mark Lenters and I and a handful of others, in helping communities out and providing smaller roundabouts in their communities. And by the way, still achieving your goals. So how can we reduce costs, but not their effectiveness? And that's an important question to ask ourselves. From my perspective, it's 3. And for some of you that are really busy and or really experienced in construction, it's pretty obvious. 1, less earthwork. So here in Washtenaw County, we don't always able to do this. And especially considering I said that we're in a rural, we have a lot of these that are built in their suburban or rural environment where I have no curb and gutter. I like to bring a pulverizer in, and unlike traditional work where you cut down to clay grade and build up from there, What's underneath is still frankly good. There's nothing wrong with it. It still drains. So I pulverized the existing asphalts that there. Then within the roundabout itself, the inscribed circle, I'll widen, put stone in. But essentially what I'm doing is I'm leaving everything there with the pulverizer. We'll shape it. We'll move it around. We'll get density. And then from there, we use it. So the less, we're not double handling material. We're not trucking material. That saves us money. Second, anytime you can reduce storm sewer, you're going to win. Most of my roundabouts, my smaller roundabouts here, have approaches of 300 foot, give or take. And as long as you're under that mark, you can use, you don't need storm sewer. Not always. I try to limit it though. What I do is curb and gutter with spillways draining into ditches. Again, if I'm in a very urban environment with sidewalks and curb and gutter, that's not possible. But when you can, try to limit your storm sewer, because that's going to be less material and less time to have to construct the roundabout itself. And then finally, production paving is what really brings in the dollars for roundabout paving. Roundabouts are not production paving. By production, I mean you take the paver up to the flow boy and material mix goes into the hopper and off you go. With the roundabout, you have a lot of stop and go. Here you see a picture of a front end loader with the bucket transporting mix from the flow boy to the hopper of the paver, and then it's moving around the circle. But with that smaller footprint, if you can get that material built in a half day, that in theory, that crew can then go to another site that second day, mobilize to another site where you're not being billed for the entire day's worth of work. So there's some dollar savings right there. So from that perspective, those are the three main ways that you can reduce your cost. I want to state this is very important too, because sometimes they'll get it hung up on cost here. The dollar figures that I'm going to quote you, although substantially cheaper than what I have been building in the past. One, it's gone up a little bit since these projects have gone in place, but two, every market is different. I'll give you an example. Out on the East Coast, it's harder to get material and labor prices are more. And when I quote a number of say $400,000, Connecticut DOT will tell me, hey, Mark, I can't get anywhere near $400,000. I said, I get it. You might be right, but put it in perspective. They're telling me it costs $2.5 million to build a traditional size roundabout. If you're able to do a smaller roundabout for say $1.5 million, you're winning. You're going to get $1 million savings to be able to use for other uses. So although you may not be able to get the figures that we can get here in Washtenaw County for whatever reason, you're still, when you compare it to your neighborhood and your market, you're still going to likely be winning when it comes to reducing your costs. So that's just important for you guys to keep in mind as we're going through the slides here. So where it all began at Pontiac Trail and 7 Mile Road. So in 2013, this is actually Mr. Lenters' design here. It's a four-way stop, always stop controlled intersection. And the goal was to increase capacity because at PM peak hours, it backs up quite a bit on Pontiac Trail, which is up and down, 7 Mile is left and right. And with this 140-foot ICD, there was a general store, party store, for those of you that are familiar with the Midwest term, where you can get your liquor and other things. It would have been frankly a total take had we shifted the right of way onto their property. So we put the footprint onto the west side, both the northwest and southwest corners. Those were zoned for commercial use, but they were still in development concept only. So here's some background information. Pontiac Trail has average daily traffic of 7,600 vehicles per day, 7 Mile Road, 4,600. Design speeds of approaching vehicles, 55 miles an hour with 3% truck traffic. Where things came apart from a fiscal standpoint was the amount of right-of-way that was needed. So as I told you, we shifted the footprint of that roundabout over to the west, and so that we didn't have to have a total take on that party store on the northeast corner. Well, lo and behold, we ended up needing 0.55 acres, just over a half acre. And we were of the opinion that it wasn't going to cost that much, frankly. We were guessing in the neighborhood of, say, $50,000, give or take. Well, we ended up going through the formal process of an appraisal, and to our surprise, it came over $100,000. I think it was close to 120. Well, the property owner who owned both corners there was seeking $300,000 plus. And we're just in no position to be able to come close to a number. So ultimately what we had to end up doing was canceling the project, return the federal aid, which in this case was CMAQ dollars, and it sat until last summer, where we actually built a mini roundabout of an ICD of 90 foot and needed substantially less right of way. But this was kind of a disappointment, not kind of, it was a disappointment. It was a setback because, you know, it was a need. It was our #1 rated intersection when it came to capacity needs to do something. So, yeah, it stung. It stung that we weren't able to make this project go ahead and start. So that led us to our first roundabout project at Textile, Hitchingham, and Stony Creek Road, which occurred in 2015. So more or less 6 months later, we had an informal meeting internally, and the people within the organization came to me, knowing that I was going to lead the charge of the design, and said, Mark, what do you think? Should we put a roundabout or a traffic signal there? And the first thing that came back to mind was how we got stung at Pontiac Trail and 7 Mile Road. And I was like, well, maybe we should consider the concept of a mini roundabout. And everyone at the table kind of looked at me like, what are you talking about, Mark? Like I had a third eye on my forehead. Well, Wei Zhang is a mini roundabout expert. He is a representative for the Federal Highway Administration out of Virginia. Perhaps some of you know him. And I met Wei and saw a presentation of his at one of the roundabout conferences that stuck in my head. And I asked myself, would this be a good candidate to put mini roundabouts in at these two locations? And Mark Lenters would be the first one to tell you when I floated this idea to him, he's like, I don't know, man. But we both agreed, let's go talk to Wade. My bosses agreed, let's talk to Federal Highway, see what they have to say. So here's the layout of that intersection. So Textile Road runs from side to side. Stony Creek Road is on an angle. Hitchingham Road runs up and down. So the only two intersections we were looking at was on the Textile Road corridor. They were both all-way stop control intersections. And the problem what was happening was that it took 20 minutes at 8 o'clock to get through these two intersections combined because of the four-way traffic. And there was a school that was built on Hitchingham Road to the south by 1 mile. It's called a charter school. And in Michigan, charter schools are not allowed to have busing. So mom and dad is driving their children K through 12. In some cases, the students are driving themselves to school. So with them being always stop control intersection, the goal was to increase traffic. And ultimately, when I approached Wei and talked to him about this conundrum and idea, he agreed to look at our data and see if it would be a good candidate. He was looking for people to have projects and do some before and after analysis. So some background traffic here. Approach speeds 45, 55 miles an hour coming in. You have the ADTs of 66, 68, and 42. So relatively well balanced and 4% trucks. And lo and behold, Wei Zhang, after looking at his software, said, yes, this is going to work, and it's going to work really well. It's going to be a little bit on the upper end as far as what it can handle capacity-wise, but it can work. And if and when it gets to the point of oversaturation at the PM peak hours, then you could utilize, put another roundabout at Stony Creek and Hitchingham to use as a bypass. This is the footprint that we ultimately went with. The ICDs were 90 foot. And then the total cost for both roundabouts were $800,000. So that was $400,000 per roundabout in 2015 dollars. So again, don't get hung up on that $40,000. Maybe you can or cannot get that close in your community in the southeast part of the country. You have a better chance than you will in New England states. But my point is that every market is unique. Now, one of the trade-offs I want to warn you about is these roundabouts do break under traffic. By breaking, what I mean is you'll get a level service F. And it doesn't really matter what your ADT is from my perspective. It's all about your peak hour factors, because that's how you rate a roundabout as far as you look at it as can it handle the peak hour in 10 or 20 years out, undergrowth, reasonable growth factors in that time. And if you start getting into 1,500, 1,600 vehicles in the peak hour, from all approaches, chances are for a 90, you're going to start stressing it. It'll work like it does in this case, but you're not going to have a lot of room left for capacity should things expand and grow in the area. So maybe you want to increase the diameter, just say 100 or 110, which is still cost savings compared to a traditional 130. But the point is that you have to be very mindful of what your traffic volumes will be going into these intersections 10, 20 years out, so that you're not criticized, say 5 years down the road, and you're experiencing a level of service D, E, or F because you didn't account for the right amount of traffic during its design life. So let's talk about the right of way. I was talking, in the the Pontiac Trail and 7 Mile intersection, how we needed 0.55 acres. In this case, with the 90-foot ICD diameter roundabout, for the Textile and Hitchingham intersection, we only needed 0.03 acres for that intersection. And then for the one at the angle on Stony Creek and Textile, just 0.01 acres. So a total of 0.04 acres for 2 intersections, for a grand total land cost of $3,575 in 2014. That's huge. That's huge because that's a 90% reduction in area compared to traditional size roundabout. Now, keep in mind that every zoning is different as far as the land goes, but it's really all relative, because if it's zone commercial or zone farming, it's still going to cost you less. It's just going to cost you substantially less if it happens to be something that's not agricultural in use, especially if it's zoned industrial or commercial. So the mini roundabouts will give you a big win when it comes to less need to purchase right away, and also reduced impact on the property owners that are right next to the project occurring. So let's talk about the center island of itself. So what makes a mini roundabout different from a regular roundabout? Frankly, not much, other than the fact that because it's smaller, the circulating roadway is smaller in nature. The larger trucks or farm equipment, so we're talking about combines, if they happen to run with their heads on there. In Michigan, they don't. They typically tow those behind on a pickup truck. But they off track onto the center island. Now, this is not Textile Road. This is a different roundabout I have called Moon and Bemis. But you'll see there that all the off tracking in every which direction, which makes it a great example of how when trucks are turning left, that's what it's there for. So you don't want to put something in your mini roundabout in the center island because it's there for off tracking to turn left. And in some cases, right, if you got a pretty skewed angle. So you'll need to put some type of apron in. We raise ours 3 to 4 inches in height. And we do that because it still allows the trucks to be able to off track and make their left turning maneuver, but it also discourages vehicles, the sedans, from driving up and over them. Our first runs at Textile and Stony Creek and Hitchingham were flat. And I'd say about 15% of the traffic in off-peak hours just disregarded it and did a direct left across it. Not a big deal. It was concerning to some residents in the area when they witnessed it. So we ended up just raising the island a little bit, give us just enough a deterrent where people in sedans didn't want to drive. They forced them to drive around it, but the same token was more than adequate for trucks to be able to turn left over. So we talked about what the goal was to increase capacity at these intersections. So here is a before and after of what that intersection looked like. Remember how I told you it took 20 minutes to get through there at 8 o'clock? Same time period after the roundabout was built in September. Took from memory, we're talking 30 seconds or less. In many cases, 15 seconds. So for $400,000 in that time period, not only did we win on capacity, we won for safety because we have the proper entry deflection coming into the roundabout itself. And also, if you're concerned about the environment, like some people are, there's fewer emissions going into the atmosphere when you compare the two pictures on the left and right. So all the way around, a lot to offer there. All right, I'm gonna take a quick drink here as we segue into the Baker Road roundabouts. So Baker Road is an example of a larger size roundabout that you can utilize where you have more commercial trucking. More trucking that you have, chances are you're going to want something a little bit bigger. So a little bit of background here. This was done in the city of Dexter. There is a school complex, Dexter Community Schools. And what this road, Baker Road, connects to Interstate 94, 2 miles to the south. And then Dan Hoy Road is an industrial road. It's an all-season road that connects to an industrial park, as well as Baker Road is an all-season roadway too. So we have a lot of WB67s commuting back and forth from Interstate 94 to make deliveries to the industrial park 5 days a week. So we had to have two intersections that made sense to accommodate these truck traffic. The city of Dexter, we had the Shield Road. When I say we, Washington County Road Commission had jurisdiction of Shield Road. Parents of new drivers at Dexter High School at 2:30 were concerned of their children pulling out, which was a two-way stop controlled for the apartment complex in Shield as they're pulling out to turn left on Baker to go into town. It's 55 miles an hour coming in, sometimes higher, that they felt like a project needed to happen to slow down those speeds. City of Dexter heard about this and said, hey, let's work together in tandem and do something similar so that it just made sense. So the City of Dexter owns the Baker and Dan Hoy roundabout. So together we combined to put a roundabout project together. Ben Wilkinson out of Madison primarily did this under Mark Lenters' leadership. Where you see the footprint here, it's oriented a little bit differently, where Shield Road is to the left and Dan Hoy Road is to the right. And both of these have an ICD of 100 foot, but the one at Dan Hoy Road is skewed 105 to 95 in the shape of elliptical. And the reason being is that there was a cemetery there with Civil War veterans buried right in the corner there, and we had no desire to basically transport them someplace else. So we got creative in where we could do, so we didn't have to exhume the bodies. And that's how we came up with the oval shape, and it worked out fairly well. Ultimately, we ended up having a third partner come along, Dexter Community Schools. That was a key intersection before the project happened. They wanted to have another point of ingress egress for traffic for football games. So basically we worked with them and they became a third funding partner to make that turn that into a four-way legged roundabout. The total project cost in 2018 dollars, this is a completely urban environment. So with street lighting, with sidewalk, with curb and gutter, with storm sewer, 2 roundabouts, $1.3 million for an ICD of 100 foot. So again, pretty substantial savings when you think about for many communities, a traditional roundabout, you're paying $1 to $1.5 million just for one roundabout. So, and it worked out really well. So here's some ADT, Baker Road, 1,400 vehicles per day, Shield Road, 3,200, Dan Hoy Road, 58, and you can see the speeds coming in. Now the truck traffic sounds low at 3%, but keep in mind that when you have 14,000 vehicles per day on Baker Road, that's why that number looks so low. Here's the end, the footprint of the final project via a drone. You can see a WB that looks like to me it'd be a 62 turning left from Baker Road onto Dan Hoy Road there. And that's what that apron's there for. It works very well. Now this one happened to be big enough where the city of Dexter was able to put some landscaping there in that little dot there, just to give it a little bit of spice so that as it's an entry point coming into town, which is fine. That works out well. But the other roundabouts, when you have a 90, you're not going to have enough real estate to put something like that into your center island design. So here is an example of trucks going from Baker Road to Dan Hoy Road, both inbound and outbound. So you see there's a dedicated right turn lane there because the volumes warranted it. So I'm standing on the cemetery corner there. I'm elevated up in the air. Very important load there, Miller Lite. He waves to me, he waved back to him. Now you're going to notice here that the truck's going to off track onto the center island. And that's okay. That's what it's there for. That's what it's designed for. And it goes up. A little bit of a shift, slow speed, and off it goes to Interstate 94 to wherever its next destination is. So mission accomplished. Big success in the community. This, oh, by the way, has pedestrian crosswalks for Friday night lights. We don't have time to show you, but it works out very well to accommodate pedestrian use well, from small tykes with grandma and grandpa to unsupervised teenagers going to the football game. So let's just conclude here, talk about drilling for data and what I've learned here. So improved operations, the Moon and Bemis. So for an all-way stop controlled intersection, now I didn't present, in a longer presentation, I gave you some background on this, but this had an ICD of 82. And the total cost of this one to a contractor was $300,000. That was an all-way stop controlled intersection and it had a level of service of F beforehand. once we had peak entering traffic volumes of 1,500 at the peak hour, once we built that, our operations increased substantially for $300,000 to a level of service of B in the AM of 13 seconds overall, and then a PM peak of A at 8 seconds. So when you think about that, that is a lot of bang for your buck when it comes to having to do more with what you have available to you. But let's talk about that one trade-off, the most important trade-off that comes with this. I promise you that under most circumstances, you will have an increase in what we'll call PDO crashes. In Michigan, we call property damage only. Many states call them the same thing, but perhaps your state's a little bit differently. Or I like to call them fender bender crashes or a deductible crash, where everyone walks away, no one's hurt, you pull the car off to the side of the road, and you end up having to take your car to a body damage shop. With many of our always stop controlled intersections, we were having about 5 crashes per year. And in many of those crashes, people were getting hurt. In some cases, they were getting killed because they're getting T-boned at a 55 mile per hour speed or higher. It happened in more than one intersection, okay? But when you put in a smaller roundabout, a mini roundabout, anywhere from the size of 9 to 100, 110 of an ICD, you're gonna have in total somewhere between 8 and 15 PDO crashes per year. And if you get hung up on the number, 5 to jumping from 8 to 15, people are gonna be like, oh my gosh, you made this intersection worse. How could you be so ignorant? How could you be so careless in what you're doing? My perspective is completely different. No, we made it safer. You can't, not every crash is the same. Every crash is unique in its respect, just like every roundabout is unique. And when you look at all the factors when it comes to reduce costs, reduce impacts to the property owners, reduce right-of-way costs, reduce time to construct it. So you have detour routes that are less in duration and time, because that's time is money to people. Fewer emissions into the environment, increased capacity. People are not getting hurt. Although there's a spike in the PDO crashes that are happening when you factor everything else, we here in Washtenaw County are of the opinion we're doing the right thing, and we're being fiscally responsible for what we have available to us to deliver in both capacity and in safety. So I just want you to be aware of these figures as you go into it, because I don't want you to get caught off guard, because for some people, you know, maybe their mayor, maybe their city council, maybe their county council be like, no, that's not something politically we're willing to do. So be it. Here in Washtenaw County, it is something that is acceptable for the most part. And we have been given the green light and basically asked again and again, hey, you should build a mini roundabout here, there, and other places where it makes sense to do so. Okay, that's the biggest trade-off I wanted to bring to your attention. So let's finish up by recipes for success in the world of Mark McCulloch. I would start with the minimum ICD of 90 foot. I have gone less. It gets trickier, and your PDO crashes tend to go above 15 if you do that. So from my perspective, the base is 90, work up from there. You're not going to get a substantial cost difference by going below 90 foot. I learned that. The sweet spot, 100 to 110, that's when people come to us and say, hey man, I really like that roundabout. Can you do something like that again? From my perspective, all-way stop control intersections are better at mini roundabouts than two-way stop control intersections. And that's because people are already conditioned to stop. That's important because when you're doing a two-way stop controlled intersection on 2 of the legs, they're not conditioned to stop. Now, that's not to say you can't do it a lot, but it's very critical at that point. You have excellent entry angle deflection coming into the roundabout so that they are ready to slow their cars down to 25 miles an hour, give or take, through that roundabouts. Use realistic growth factors, because if you don't, your numbers are going to be so flawed in the sense of it's going to tell you that you're going to be way above 1,600 vehicles per hour. And it's going to tell you you're going to need something bigger when in fact you probably don't. Buy-in is critical. Make sure you talk to your fire chief, your police chief, and any other person. In Michigan, we have townships, and now those are our stakeholders. So we talk to our township boards, making sure that they understand why we're doing a project like this. And for the most part, they've seen enough of them to know that we're on the right track. And then monitor your results, because if you don't know what you've done, if you don't see firsthand how things are reacting, you can't make adjustments. Just because it works here in Michigan may not necessarily work in your community for whatever reason it might be. So with that, I'm going to hand the baton over to Mr. Lenters, and he's going to take you into the next aspect of roundabout design.
All right, thank you, Mark. I'll go ahead and introduce Mark Lenters, or Mr. Lenters. That's a good way to distinguish between the marks here. Now, so our next presentation is making data-driven decisions in design of roundabouts. Mark Lenters is a transportation engineer with Kimley-Horn. He has 34 years of continuous intersection safety and design experience. Mark is he's recognized as a national leader in roundabout design and safety reviews based on 20 years of full-time roundabout practice across the US and Canada. He's a member of the ITE and TRB National Roundabout Committees and is assisting with the next National Roundabout Guide. So with that, I'll turn it over to Mark.
Thanks, Josh. You can see my screen?
Yes.
All right, it's terrific. Thank you, Mr. McCulloch, always inspiring. We both have a common purpose to help agencies achieve the most in congestion relief and crash reduction using roundabouts, and albeit low cost as well. So not everybody can tap into that without federal funding. A lot of federal funded projects, you have the NEPA process you have to follow through, but Mark gives some great examples, and it's been a privilege to be part of his action. I like that saying, there's nothing more damaging to an opinion as a number. And maybe through some of this, you'll...
Teams audio.
Excuse me. Trying to shut that off. Try that again. They find a way to reach you anyway. So in this presentation, I'm going to show some of the methods of in-service review of roundabouts. In the first presentation, you're seeing cutting edge. In the last presentation, you're going to see guidelines. And in the middle, we're going to work on some data collection. I'm sorry, I have to turn that off.
See, this is how important Mark Lenters is in the roundabout community, where everyone wants to talk to him. I think this is great.
Thanks for that. So there's been recent improvements in reference statistics for crash analysis, and I want to go over some of that. It's really exciting. It's been almost 10 years since we've seen a real update to the collision prediction model development. But both, the in-service review methods and even the recent statistical improvements, they still point to a need for more precise data collection. And I want to kind of finish off with that. And a shout out to Mark Traffic, Murray Allen, who I worked with on some of these studies, and he worked with one of my West Coast partners. The point of this is we want to produce an evidence-based, data-driven analysis of roundabouts, particularly in service. The safety models are coming along, but they're still weak. So we're very humble by the fact that we don't know everything there is to know, and we try to work from geometric conformance through to safety prediction models to develop our toolbox for in-service reviews. So I'll show you a couple of examples. So in this example, if you look at the left-hand side, there's the traditional study design for conventional intersections and in-service reviews. It also applies to roundabouts. It's essentially FHWA's safety audit toolbox. And the office review is highlighted. It's the area where we develop our understanding of the problem, and we get good knowledge of the intersection condition and the crash conditions before we go to the field. Currently, at a national level, we have planning level and intersection level models to predict the frequency of crashes, annual crashes per year. Intersection level being total per intersection. And they've been very useful for the conversion of other types of intersections to roundabouts, two-way stop to roundabouts, always stop signals to roundabouts. But we haven't had models to reveal the relationships between crashes and geometry. Those have been developed overseas in the UK primarily. But in the US, there's been a drive to develop leg-specific models of how the roundabout entry and approach performs in terms of crash frequency based on its geometry. The example shown here in the highlighted image there is a site in South Carolina, SC46 and Bluffton Parkway in South Carolina. I happened to pick it. I was involved in a review of the in-service conditions a few years ago. It clearly has a high frequency of crashes, but the important thing in this kind of a study is to attach significance to it. I'm sure there's a high number of crashes, but is it a significant pattern? And so what you'll see, if you can focus in on this, is the entry circulating and exit circulating crashes, and particularly the exit circulating crashes, appear to be overrepresented. Obviously higher than all the other patterns, and potentially higher than patterns at any other type of two-lane roundabout with volumes in the range of 25 to 30,000 vehicles per day. So this roundabout's been looked at a couple of times. I looked at it back in 2017, 18, and made a presentation to the county. With the high frequency of crashes, again, the question is, how do we attach significance to those? How does the percentage of exit circulating crashes compare to other types of other roundabouts, or even the national data set? We can compare the total crash frequency from site to site to the population of similar roundabouts using intersection level SPFs and daily volumes, but we haven't been able to do any more than that, which leaves us starving for answers and applying more engineering judgment than statistical confidence. So I'll go over how I developed some relationships between geometry and crashes, a much more rational approach to it rather than a numerically driven approach. But that's all we had in terms of methods, and they're indirect in the sense that we can't create direct relationships between geometry and crash frequency. The development of crash prediction models comes from NCHRP 888 most recently. There was some work done in 2005 and some intervening work done on the data set, but a major update to collision histories on roundabouts and safety performance functions is NCHRP 888. It confirmed relationships between crashes and geometry, but not for all conditions, and particularly for this type of roundabout, a 2x2, where it's two lanes entering from every direction, crossing two lanes, exiting two lanes. So we have 4 conflict points at every entry. So it's probably your worst case of two-lane or multi-lane roundabout. So questions we have to answer. We can identify crash clusters, but how do we attach significance to the documented pattern? We risk identifying false positives. I've done a number of in-service reviews, and we try to sort out whether we think it's a problem or is it really a problem. But without reference statistics, it's difficult to say that the site has significance within itself or compared to other roundabouts that justify investing a lot of money to fix a problem when, in fact, it may not be a significant crash condition. So we still go ahead sometimes with costly countermeasures, and that's the mistake that engineers can make, is solving non-problems. So I want to show you some of the update to the collision data set, nationally speaking. And in the chart on the left there, the entry circulating and exit circulating crash patterns are the most prominent. So we look at roundabout crash types, entry and exit circulating, rear end on the approach, single vehicles that run off, roadway departure, and circulating, typically side swipes, and single vehicle circulating and exiting, and then that gives us the total crashes. So by statistics, we're seeing roughly 60%, here 35%, and this is two lanes circulating, two lanes entering. So there's our 2x2 combination, and you can look, in each case, a high percentage of entry circulating in the patterns. So we're concerned about these, and this is what we need to attend to because they tend to be the higher severity crashes as well. So these SPFs that were developed for 2x2 roundabouts, 1x2 circulating lanes, give us intersection level crash prediction. And that's new. We didn't have that at that level to look at a crash type below the intersection level. It's good news, but it still doesn't give us enough information to determine whether the individual crash type is significant. So what we can come to the conclusion of and compare to our statistics for a particular site is, what's the percent of this crash type at the site, and how does it compare to the national model? And so you can look at comparisons between sites and urban and rural. The new SPF tools from NCHRP 888, they improve the testing for target crash patterns, but only really give us the percent split. We still don't have something that drills down to the specific geometry, things like entry angle and ICD. It's a little bit elusive. It'll take time to collect that data. But you can see what we have is, let's go through the next one here. So SPFs for the 2x2 case, the models have been attempted. This is the form of the model. These are the parameters: intercept, entry, ADT, so volumes, and then things that pertain to the geometry. And we still have some holes. We have several options of models, and so this is a work in progress for entry circulating. And for exit circulating, we don't have very much available. So in the example that I showed you, you could see that we have a problem with exit circulating, a serious problem with high incidence of exit circulating crashes. So all we can get right now with these models is the percent crashes in terms of the percent of the whole for that site. But we don't have a safety prediction model. So that's still something we need. Nevertheless, we moved on with the project, and without fully developed models and weak crash prediction at the geometry level, we turned to engineering judgment for some of the support. And I'll show you some technology towards the end of the slide set that's going to improve our ability to do crash prediction at the geometry level. So in the field review, this roundabout was built about 7 or 8 years ago. Annual frequency of crashes actually did reduce in the conversion from signal or stop control to roundabout, and so did the crash severities, but not sufficiently to be deemed a success. So I'm going to give you a quick overview of the study and the solutions, and show the point where we departed from the ability to be data-driven and went more in the direction of engineering judgment. With the current NCHRP 880, we might have had a better chance to at least identify the percentage split with confidence and say we do have an overrepresented condition of exit crashes, and that will help drive the justification of the improvement. That confidence in the data, that confidence in the analysis of that crash information. So ultimately, engineering judgment played a bigger role in the development of the results, using a more rational method and not so much data-driven. I was asked to review the conditions in service and suggest some possible countermeasures. The office review, which is essentially the crash diagram and geometric conformance, identified that possible target crash pattern of entry circulating, exit circulating, as mentioned, but not with absolute confidence. So we turned to the field review and sought to identify causal factors with a focus on entry circulating, exiting crash patterns. And what the observation showed us was that drivers were not having sufficient time to cross the gap, essentially the gap being the sketched green area. These lines effectively are the measured distance the driver has to cross this gap area, or conflict areas refer to it. And so what we did was measure that and compare this design, which is somewhat radial and large in ICD. It's a 202-foot ICD. We compared it to a more conventional left offset design that might have been about 165 feet in diameter. And what would the conflict areas and the conflict crossing distances be associated with that? And through that, we argued that if we can reduce the conflict area, if we can reduce the gap crossing distance, then surely the crash frequency should come down, because it makes it easier to judge gaps. What I observed was drivers would come up to the yield line. They weren't flagrantly ignoring the yield and driving a fast path. They would come up to the yield line, stop, look left, and simply not be able to judge what's an adequate gap because of the size of the circle and traffic coming fast from two directions, lefts and throughs. They couldn't judge what was a safe gap to get across. So had we had a safety prediction model for two-lane crossing two-lane, that would have accounted for geometry, and we might have made a more confident prediction. So as it was, judgment played a bigger role, as I mentioned. So you'll see in a minute, it's subtle. I'll compare the alternative design for the intersection or the roundabout to what was built, but I'll go through a couple of lower cost immediate measures that showed some promise. And this is something we've seen in many states, the idea of overhead lane designation. So at least we sort out the lane choice problem so people aren't making lefts from the right lane. And that will help the situation. There were a number of sideswipe crashes circulating, certainly not an overrepresented pattern, but at least wayfinding would be minimized. And then to turn to education as another remedy, helping people understand what lane to pick for what movements, And these are education pieces that we've had in circulation with many agencies. Another option for a medium term countermeasure was to look at a hybrid roundabout, essentially in brute force way, reducing the number of conflict points in half, just essentially 2 by 1 with the right turn, still having a conflict point, but only with the right turn exiting traffic. But this, in a sense, it's going to cut capacity down too. And here someone's constructed a 2-lane roundabout, and we're going to lose 1 through lane through and left, and the availability of all that extra throughput capacity because we're cutting out 1 through lane and making it a right turn only. So while this can be done and it would improve safety, it's more costly and it would degrade capacity. So ultimately, and this is where you compare the existing intersection to a proposed, and the blue line of the proposed is effectively a smaller footprint within the same footprint, but it's more left offset. And left offset helps to square up the entries, it reduces the entry angles, and by doing so, it reduces the conflict space. So in a rational sense, we justified the improvement as being crash reducing by virtue of just the length of gap crossing and the conflict area being reduced. Now that's not a model, that's somewhat engineering judgment. And so it would have been nice to have the NCHRP data to support us and dig a little deeper into that data set to see if we could pull out some of the geometric parameters that might justify something a little less costly than this. So information that wasn't previously available for safety reviews includes things like speeds, conflicts, as I've been looking at with the patterns observed in the fields. Truck tracking is another big one. We can't generate precise measurements of those things, particularly speeds. And significance testing of crash patterns. We haven't been able to get good confidence in that at the intersection, below the intersection level at the geometry level. So capturing statistics on in-service conditions and reference statistics for significance testing has been difficult. So turning to drone video analysis with emerging collision prediction models is going to afford a more comprehensive understanding of roundabout functionality, and there are many things that it could contribute to in the future, and I'll show you a couple. So that gives us recommendations that we can make for an in-service review to update geometry, markings, lane width, signage, and so on with greater confidence. So our traditional crash diagrams, and this is a study from a site in Ohio, we've always been able to identify crash clusters, but how do we attach significance to the documented pattern? In other words, when is the pattern significant, not only for the site, but compared to other roundabouts? So without good significance testing, we risk identifying false positives, as I've mentioned. And we think it's a problem when it isn't, and then we go and spend money. It'd be like going to the doctor and having a gallbladder operation when it's actually your appendix that should come out. Historically, as a practice community, we've sometimes gone ahead with costly countermeasures without the highest degree of confidence. So a new technology solution, and this is something we've worked on with Murray Allen. So shout out to Murray for, let's see if I can get this video going. There we go. So vehicle detection, vehicle tracking, it's a pixel, it crosses a video image, it can be tracked using an algorithm. So MAR recently partnered with Kimley-Horn on roundabout data analysis projects in California, Ohio, and Georgia, with a particular focus on safety and operational challenges. High quality aerial view obtained using anyone's drone was fed through to MAR, and they post-processed it using artificial intelligence software and algorithms to analyze the video. And some of the things that we can produce obviously counts, but vehicle tracking patterns, which include speeds, lane discipline, lane changes, fast path, driver interaction, and conflicts in particular. And it gives us the ability to get heat maps for showing high volume areas, high conflict areas, lane change areas. So this is really the future of in-service reviews, to do what we couldn't do standing on the ground and just observing traffic somewhat casually at times. All right. So truck tracking is another one, and lane changes. You can see some of the blue lines crossing lanes. So we're concerned about that sort of thing, whether it's because it's a fast path, but and identify what peak period that's, and whether it's off peak, just to determine whether we've got problems with lane changes and sideswipe issues developing from that. So you can look at some of the speed data, and in our results, our average speeds, our 85th percentile speeds, and even the max speeds, although they were quite high, we were surprised that the 85th percentile speeds were actually fairly conforming. And with the vehicle tracking technology, we can track the speed anywhere along the line, anywhere along the vehicle's path. So in this region, we can track the vehicles in this region and circulating and exiting. So we can compare them to the models that we have for collision prediction, using speed as a surrogate of safety. And that's the R1 fast path concept. So this one has a geometric entry speed of 31 miles per hour. It occurs way back from the entry. And so the driver can actually accelerate from roughly the crosswalk area, if there is one, all the way through to the exit. And yet drivers were somewhat relaxed about that. So the crash incidents we saw at this entry was more really attributed to the paint condition and the fact that the yield line was hanging way out in relation to the physical built condition of the curb head. So drivers didn't really know where to stop. And we had a number of rear end crashes occurring here and some entry circulating crashes because they could accelerate through from the big hook or hockey stick, as it's sometimes referred to. So the ability to analyze lane changes and sweat paths in this little diagram area shows some of the conflict patterns for entry circulating conflicts. We can see some of the rear end conflict patterns, and these can be derived statistically for however many times you sample. It doesn't have to be consecutive sampling. You can take 20 minutes of drone, come back and take 20 more minutes of drone in the rest of the peak hour. And then it's the sheer number of conflicts that you can correlate with observations of crashes and vehicle conflicts can eventually help us improve our collision prediction. Another thing that they're very good at is tracking trucks. And we can look at truck sweat paths as well. The geometric outline of the truck's body can be tracked and taken through the roundabout, and we can see whether there's lane discipline for truck drivers. We have a category of design case 1, 2, and 3 that truck drivers sometimes don't exercise, and we're not sure. This is a very large roundabout with 3-lane entries, and lane discipline is certainly achievable because the entry circulating lanes are very wide, and yet truck drivers will sometimes still cross lanes, and that depends on whether it's peak or off peak. So vehicle tracking, vehicle detection tracking holds great promise for collision prediction. In the signals world, they've been doing it now with real-time cameras 24/7, and they're taking safety performance functions and improving the quality and the confidence in those SPFs by continually sampling conflict patterns and correlating them with collision history in those intersection locations. The key variable is time to collision, and the area that we're struggling with, and we need some help from research, is time to collision. Is it 0.03 seconds? If you run this model, this algorithm with varying time to collision, you'll get more or less conflicts. And what is the right number? And we're going to need help from research from a university or FHWA and a university to sort these things out. This isn't something the average roundabout designer can fathom. So we see these great promise in these tools. So the algorithms are needed to improve current SPFs, and particularly the NCHRP 888 algorithms crash prediction models could be improved through vehicle detection as a surrogate for crashes, detecting conflicts and correlating that with crashes to improve those models. So just coming up to the finish here, it's really about getting more confident conclusions using a data-driven approach. Drone video detection and artificial intelligence can be used in follow-up studies as well, in monitoring sites, improving the effectiveness of an implementation. So our current methods haven't been sufficiently data-driven to develop high confidence in countermeasure recommendations. So new models are helping confirm whether an intersection has a significant problem at the leg specific level. And since SPFs are not quite there yet, we can turn to some of the drone data collection and video detection to help improve the quality of those models for crash prediction as an aid for future SPF development. And you can see with all the different opportunities with trucks, speeds, we're getting a much more precise data collection using drones than any of our on the ground observations could afford. So I think that's it for my time. Thanks everybody for listening, and I'll turn the screen back over to Josh.
All right, thank you very much, Mark. That was excellent to dive into some of the details there and see how see what some of the data is showing on from a safety standpoint. So thank you. I will remind you all to keep the questions coming in the Q&A button chat, and we'll hit those after this this third session. So keep the questions coming there. Our next session is on the Roundabout Design Guide, and Chris Raymond is from Georgia DOT will be presenting. Chris is a state traffic operations manager over both the project review team and the Roundabout and Alternative Intersection Design team in GDOT's Office of Traffic Operations. He's been with Georgia DOT for 10 years, working in various capacities, such as construction project engineer, traffic operation plan review supervisor, and area manager. Chris graduated from Kennesaw State University with a degree in civil engineering technology. And with that, I'll turn it over to Chris. My puppy's really excited about this. Go ahead, Chris.
He should be. I'm pretty awesome to listen to. Yeah, my name is Chris Raymond. Like they said, let me go ahead and share my screen. In typical Mark fashion, they left me with not a lot of time to talk. Let's see. You guys see that now?
We're seeing the wrong screen. We're seeing your note. There you go.
Okay, cool. So yeah, honestly, I think at this point, Mark should be like a doctor title for Roundabout expert at this point. I think I'm gonna petition for that. So yeah, we're gonna get into pretty quickly, so you get some time for questions. Just a bit of a high level look at our Roundabout Design Guide, what we've put into it, what we think is important, and things of that nature. So getting started, we're going to go over a little bit of a background on why we thought it was important to develop this guide, and then get into a little bit of the meat of the document, the geometric design aspects of it, traffic control devices, and then how we've kind of integrated practical design throughout the document as well. So a little bit of background on roundabouts in Georgia. As you can see in this graph, we've got over 70 on state routes with 50 single lane, 5 multi, 10 mini. Well, the big number that stands out though is how many we have under construction currently, which is almost a third of how many we have on the ground right now, and well over 100 in design. And so what we're looking at, kind of forecasting out that that really we're not going to have the kind of capacity to really walk every engineer through roundabout design practice, and there just aren't enough marks in the world to really handle all these designs. So we thought it was very important to come up with a guide to really provide a more step-by-step process into how we want them to design roundabouts in Georgia, and hopefully give them the tools they need to do it successfully, and make it a little easier for my team to review them, because that's always nice. So things that we're looking at introducing in the guide, this is a supplement to our design policy manual. It has a very brief summary on the things we're looking for in roundabout design. So obviously, again, this is very expansive, going into how-tos and a lot of nitty-gritty details on what we think is the best way to approach a successful roundabout design. And of course, underpinned by national research, documentation, and again, that whole focus on practical design, very important. And currently we've got a version out now, but we got a final draft on a very heavily revised version, and that's kind of what we're going to go through in this presentation. So to start off with, of course, we've got the roundabout types, single, which in Georgia consists of conventional, there's 130 to 160 size single lanes, then compact, which was kind of riding that line in between conventional and mini, and we're trying to get some of that central island landscaping in there, because we see a good benefit to that as far as both aesthetics and safety, giving the driver something to see as they're approaching the intersection, more so than just a flat concrete slab. And then multi-lane, we're starting to get into a good bit more in Georgia. We've got a few bit of hybrids on the ground. We've got a lot of full multi-lanes full 2x2s that are in design right now. And one of the big things that we're bringing to this section, and luckily we're able to get this all in before we get up too many of these on the ground, is trying to integrate some elements of turbo roundabout design, which has been kind of I don't know, a hot word as of late. But we're not abandoning the principles of American roundabout design. We're just kind of cherry picking the concepts that we think would be beneficial to enhancing multi-lane roundabout design. So now getting into those geometric design elements, the first thing we want to really give the designer is make sure that they know that there's an iterative process to roundabout design. It doesn't mean you don't just directly go from a single lane roundabout to a full multi-lane. So you got to look at your layout and start from the simplest configuration and build out based on capacity needs. So you're not over designing the roundabouts, creating more conflict zones that are necessary. Getting into the operational analysis, adding right turn bypasses where needed, or a second through lane and second exit lane, or dual lefts, or however best handles operational needs without going above and beyond and putting more asphalt on the ground that costs more money and can cause or reduce the safety aspects of roundabouts. Our preferred design tool is currently Sidra. We like it. We think it's useful for younger engineers or less experienced engineers because it gives them honestly just a good picture of what they're what configuration they're looking at when they're running their analysis, and also the benefit of having a couple different formulas to work from to kind of check on your performance from a few different views. And we also have a tool, our Georgia Roundabout Design Analysis tool that is free to use, but again, we prefer, especially younger designers, use that more interactive, graphic intensive program, Sidra. And again, like I said, we're focusing on the core elements of roundabout design. What the data, as Mark Lenters had mentioned, the data that's solid, that we know, backed up by by years of research, that this is the kind of stuff that works. Providing space for trucks, focusing on refuge islands for pedestrians, channelization, and proper signing and marking to ensure people are getting in their correct lanes prior to getting to the roundabout. And one of the biggest core elements is that left offset, which again, isn't a typical design element of Dutch turbo roundabouts, but something that we're holding on to even while we're introducing turbo elements to our designs. Some other things we're showing designers they can look at to optimize the design for both practicality and safety is look at your intersection and don't necessarily assume that it has to be a circle that goes in. Look at elliptical designs, things of that nature, to kind of best fit the intersection for its needs. We've had a lot of confusion from younger designers and honestly more experienced designers on how to handle high-speed approaches, especially as you're approaching in a super elevated curve. How to transition those down without having the driver carry too much speed into the approach. So we're going heavily into how to handle that whole process. Looking at entry curves. Some best practices that the one in the face wouldn't seem as obvious, but have been shown to be effective in optimizing design for specifically in this case for trucks to keep circle size down. We're showing a step-by-step process on walking them through performance checks such as fastest paths, and giving them all the tools and tips that they need to do that successfully on the first go, and giving them more tools to work with to fit the constraints of their design. Like I said, sometimes there's constraints such as runaway take, or say there is a cemetery on one corner, so increasing circle size or moving it is out of the question. So then maybe providing something such as simple as an external truck apron could allow you to keep that compact design but accommodating your design vehicles. Walking them through accommodating check vehicles, oversized, overweight, ensuring that's all being accommodated for. Showing them how to request and receive OSOW permit records. And this is one of the things that I personally think is going to have a positive effect for introducing those turbo elements is multi-lane design with regards to trucks. I always had it in my mind that truck drivers they don't know offhand if a designer designed it for a case 1, 2, or 3. So my gut feeling, and I think the research kind of bears this out, is that trucks are going to assume that it's a case 1 basically, and that they can't fit in their lane through the whole roundabout because they've probably gone through a case 1 in the past. So I think one of the things that the raised lane dividers that specifically the turbos introduce is giving the truck driver some sense of security that there's a raised physical element that probably more confidently means to them that they can maintain their lane, either through the entry or through the circle itself. So we go through path alignment concerns, walking through the pitfalls designers may run into, vertical grade issues that designers may come across, such as high points in the truck apron, those low boys catching on as they go around, ensuring that doesn't happen. Giving them typical sections options. One of our favorite is, this particular top one is a mini roundabout, where we have really kind of embraced these things called internally illuminated bollards that provide some sort of physical element. Even on fully mountable roundabouts, those can be driven over hundreds of times by trucks. And some other things we really are pushing towards is doing on slab on asphalt to kind of preserve that existing asphalt if that can be maintained without and also helps with disrupting or reducing disruption to traffic. Pedestrian accommodations, talking specifically about situations where you have the external truck apron, how to design that without having pedestrians stand out in the truck apron, which is obviously a pretty important thing. Getting into the traffic control devices, we've got detailed drawings showing our preferred layout for signage and marking on both single lane, for mini, for multi-lane, and we've got multiple examples for cases 1, 2, and 3 that are going to be introduced, showing how to handle those raised elements and stripe accordingly. We're also introducing sections on how to approach active device situations where you're either doing RFBs for pedestrians or pedestrian hybrid beacons, or even metering signals to kind of optimize an existing design to keep from having to go out and punch it out to a full multi-lane if at all possible. We're also looking at giving designers guidance on how to handle roundabouts around railroads. That's for the most part, it seems like the railroad community is not a big fan of roundabouts in or near their tracks. But we're trying to get away, trying to kind of get rid of that whole theory that that it has to be difficult and that it can't be done safely. This is an example down in the southern districts of Georgia. Well, obviously the train tracks running right through the roundabout. was quite bold indeed. And even providing guidance on landscaping. Again, we see it more than just a pretty element. The restricting the sight line through the roundabout, gives the driver some sort of visual indication that they're approaching something more than just a straight section of roadway, and helps increase the safety aspect of the roundabout beyond what it already contributes. And looking at ways to do mountable and non-mountable concrete to kind of give better visual indication to drivers which areas are to be driven on versus which areas are to be avoided. And finally, we're getting into some of the practical design elements. Mark McCulloch was talking right sizing, but we've moved beyond right sizing, Mark. We're down into deep into practical design, which is like right sizing extreme. So minimizing staging cost. We've learned a lot actually from building mini roundabouts on some methods we can carry over into full design to both reduce cost and to reduce impacts as these are being built. Going to even more compact designs of single lanes, and again, using some staging methods to help minimize the impacts. Because one thing we've seen a lot of the costs going up is that really, I think part of it is that designers or construction companies just don't really enjoy building them when they have 5 or 6 stages of traffic to work under. So really trying to minimize those traffic staging situations to basically give the construction companies a product that's easier for them to build, and making them really want to go out there and competitively bid to get that work. Some other considerations, reduce drainage, like McCulloch had mentioned, using ditch lines instead, reducing splitter island lengths, when appropriate, on less high speed approaches, and introducing other elements such as rumble strips or more signs, other mitigations to other than physical splitter islands to bring the speeds down as they approach. Again, those quick response projects, which are for us are projects that are under $200,000 typically. We've built over a dozen roundabouts under that type, and they've provided a lot of feedback on how to do practical design in an extremely efficient manner. Here's some examples of just right sizing, minimizing impacts, and this is a great example of an original design with some really outrageous and I'm certainly very safe approach alignment, to get those speeds down, but possibly a little too much, especially for what was being designed and the cost difference between the one at the top and the one at the bottom. Giving designers better tools to do more efficient designs is really just a key element of this document. Some other practical design considerations, getting it as roundabout as soon as possible, minimizing staging, like I said, all those things. And I tried to blast through that pretty quick, but that's all I have for you guys.
All right, thank you very much, Chris. Well, we will go to some questions we've received, and feel free to throw in other questions. We've got about 10 minutes left here, so if you all have questions, we can just go and type those in, and we can address those. So this first one is for Mark McCulloch. Was on the locations that you showed where for the mini roundabouts, was a before-after safety study looking at collisions done for any of those locations?
Yeah, for a handful of them they were, and that's how I came up with the averages of 5 beforehand, and then on typically 8 to 15 thereafter, where I looked at the conditions of the roadway. So was it raining? Was it snowing? Was it dry? What time of day did it happen? And for the most part, most of my crashes are happening during the daytime, which is actually good. Shows you how important lighting is and how lighting for our roundabouts is not a factor because apparently they're very well lit. But yes, short answer is yes. And I plan to go a little bit deeper dive into it this summer with a summer help student, where we're going to look at it and assign a dollar figure for each crash that happened to see what the comparison is of before and after as far as the cost analysis goes to how it's impacting society.
Okay, great. And I think this next one is also for you. Actually, the next one is, what is the typical structural design of a roundabout truck apron? And that's, I don't, I'll leave that up to either one. I think this was entered in when during Mark. I think
I think Chris or I can both answer that question. For it, it depends on how much traffic you're getting from trucks and how often is it beating it up. But on the average, if you're from 8 to 12 inches of PCC, you're going to be fine from my perspective.
Yeah, we've kind of settled on 10 inches just across the board. We've seen that hold up very well. Well, we do get thinner sometimes. When I was talking about doing keyed in or dialed in truck aprons on top of existing asphalt, since that whole existing structure is already there, then doing as little as 5 or 6 inches has been shown to be sufficient for the structural needs, even with truck traffic.
Okay. All right, and one question for Chris. This one isn't in the chat, although if anyone does have any questions, please go ahead and put those in. But Chris, can you tell us the status of that of y'all's design guide? Is everything complete on that?
Well, there is one that's live on our website, though we've been working over the past 6 months, and hell, that thing's only been out for about 18 months. But we've been working heavily on a heavily revised version that's been seeing a lot of iteration, and I think we're right at the point where we're final draft. We got another round of kind of SME review to check for errors or inconsistencies, things like that, and then hopefully we'll have it on the street. Realistically, probably mid-May, probably. So. Yeah.
Okay, great. All right, and then here's another question just came in. Do you typically design flush outside truck aprons to better accommodate curb ramps when present? So for the outside truck aprons.
Mark, you want
to? No. Typically, it's been 4-inch raised with a rolled profile. So it does pose a concern.
Similar to the inside.
Yeah.
Sorry.
So that's the outside truck apron, sometimes called truck booster.
Yeah.
So go ahead, Chris.
I was gonna say, I mean, there definitely is a concern with with accommodating curb ramps to those conditions. We've actually recently been looking at our how we're handling that. Because we definitely don't want any kind of situation where pedestrians are standing on that external truck apron. But yeah, typically they are raised, to give some help with the speed control.
I think it's important that what I like to say is every roundabout has its own unique fingerprint, and although they have similarities, they have their differences as well. And every intersection is unique in the standpoint of what it accommodates, whether it be commercial truck traffic, whether it be pedestrians, whether it be cyclists. And I think it's imperative that it's not a cookie cutter approach. And I'm not by any ways insinuating that anyone on this call is doing that, but keep it all. It's a balancing act, and make sure that you can make this as safe and reasonable as possible when it comes to accommodating the different types of stakeholders that you have at your intersection. So it might be important to have that crosswalk to go a little bit further back. So maybe it's not in the apron behind the radius of a curve for a truck turning right. So just some things to think about when you're putting that design together. They don't all have to look alike, is what I'm trying to say in a short version of what I'm trying to say.
No, that makes sense. But there's a horizontal separation, not just some of the vertical curb profile, but there's some horizontal separation that may be needed between that blister and the ramps. Right. Okay.
Mhm.
Very good. All right. Those are all the questions that I see for this one. So we'll go ahead and wrap up for today. I do again want to thank KCI for sponsoring the session, and thank you all for attending. Thank you especially to Mark and Chris for presenting. Thank you very much for this great information. And our next session starts at 3:45, I believe. Wait, hold on a second. Is it 3:40? Maybe it's. It is 3:30. We've got a 20-minute break. So see you at 3:30. All right. Thank you all very much.